Hello everyone, we are from group 5. Today's case study will be on other example 2. This is the data. We are required to obtain a hot and cold composite curve, problem table algorithm, grand composite curve with T-mean of 10, 20, 30 and 40. Okay. From this data, we will obtain hot stream and cold stream. So from here we can see that hot stream is from higher temperature to lower temperature, whereas cold stream is from lower temperature to higher temperature. So after obtaining the 3 hot stream and 3 cold stream, we will use the adjusted temperature formula to use that temperature for the next step problem table algorithm. For the hot stream, we will minus with the half of delta T mean, and for the cold stream we will add with half of the delta T mean. For this we use delta T mean as 10 degrees Celsius.
For the next section, it's the problem table algorithm. The first thing is that we are going to take the stream temperatures and arrange it in a descending order, and here are the CP value for each of the streams. We are going to label each of the intervals from 1 to 9, and these are the subsequent delta T for each of the stream intervals. And for the CP value, we are going to take the summation of the hot CP minus the summation of the cold CP, and from there we can find our heating load for each of them. And also we are going to calculate the cumulative heating load in order to do our cascade to find out what are our hot utility and cold utility. Okay, so now looking at the cascade, we can already see that our pinch point is at the most negative value, and we are going to take this value and adding it to the enthalpy to calculate our cold utility and hot utility.
Next, we will look into the formation of composite curve. The composite curve consists of the hot line as well as the cold line, which is actually obtained from the stream data. Based on this, we have found the pinch temperature to be 388 Kelvin, while the hot utility is 4240 kilowatt and cold utility to be 7040 kilowatts. This is obtained through the adjustment of the graph between the hot and cold temperature to find the best fitted line to ensure that the T minimum is 10. Moving on to the grand composite curve. The grand composite curve is basically the adjusted cascade which is put into a graph form. What we can observe here is that we have the hot utility at the top, which accounts up to 4240 kilowatt, while the cold utility at the bottom, which accounts to 7040 kilowatt. The intervals are basically from the cascaded heating load, where you can see here will be a 4240, 1840, 1640, 1340, 100, and moving on to 0. And 0 actually indicates the pinch temperature. At the bottom, which is the cold utility, you can see a 960 kilowatt of heating load over here, followed by a 4390, followed by a 5040, and last but not least a 7040. So the grand composite curve fits as a purpose for us to identify the kind of utility that we can use for the heat integration.
So we have done all the minimum temperature differences utilizing the program hint, as you can see here, and we have obtained the results. For minimum temperature difference of 10, we obtain the heating duties of 1240 kilowatts and cooling duties of 7040 kilowatts. For the minimum temperature difference of 20, we have obtained the heating duties of 5060 kilowatts and cooling duties of 7860 kilowatts. As for minimum temperature difference of 30, we obtained the heating duties of 5880 kilowatts and cooling duties of 8680 kilowatts. And lastly, for the minimum temperature difference of 40, we have obtained heating duties of 6680 kilowatts and 9480 kilowatts for cooling duties. So, by comparing all the results that we have obtained from all the minimum temperature differences, it's concluded that the minimum temperature difference of 10 has given us the lowest combination of heating duties and cooling duties. So that concludes our case study. Thank you.